In a truly astonishing turn of events, NASA's James Webb Space Telescope, JWST, has once again proven to be a revolutionary instrument in the field of astronomy. Recently, it made a discovery that has captivated the attention of scientists and space enthusiasts across the globe. Just a few weeks ago, the telescope stunned the scientific community by identifying the earliest known galaxy ever observed, an extraordinary milestone in our exploration of the cosmos. However, what the telescope has now uncovered is even more mind-blowing. A supermassive black hole that is not only active but moving away from its host galaxy at an almost unimaginable speed of 4 million miles per hour. This discovery has profound implications. Traditionally, black holes are perceived as regions of space-time exhibiting gravitational forces so strong that nothing, not even light, can escape them. They are thought to consume everything in their path, pulling matter inward. Yet, the black hole identified by the James Webb Telescope appears to defy this understanding. Rather than sucking in matter, it appears to be casting out a cosmic trail of young, newly formed stars. This is an active black hole creating stars instead of consuming them. It's a phenomenon that astronomers have never seen before. The stellar trail is an astonishing 200,000 light-years long, and researchers believe that this is the result of the black hole interacting with dense interstellar gas, compressing it and triggering the birth of new stars. This finding was recently reported by Yale University professor Peter Van Dam led astronomers in the astrophysical journal Letters. To put icing on the cake, these findings were later confirmed by NASA's Hubble Space Telescope. Scientists had predicted that as the black hole traverses a gas-rich environment, it creates shock waves that cool the gas and trigger star formation. What we're observing is the wake left behind, a cosmic ripple effect that is both beautiful and bewildering. This unexpected behavior has raised more questions than answers, forcing astronomers to rethink their models of black hole dynamics and galaxy evolution. But that's not all the James Webb Telescope has revealed. In another exciting development, NASA announced a remarkable observation of a galactic merger known as ARP-220. This dramatic cosmic event, occurring approximately 250 million light-years away in the constellation Serpens, showcases two spiral galaxies in the process of merging. ARP-220 is classified as an ultraluminous infrared galaxy because of its incredible brightness. It shines with the power of 1 trillion suns, a stark contrast to the Milky Way's relatively modest luminosity of 10 billion suns. This merger likely began about 700 million years ago, resulting in a burst of intense star formation in a highly compact region only 5,000 light-years across. That region alone contains around 200 massive star clusters. Earlier radio telescope observations also detected around 100 supernova remnants in a region less than 500 light-years wide. The Hubble Space Telescope later revealed that the two galactic cores are separated by 1,200 light-years, and each contains a rotating ring of star-forming material that emits dazzling infrared light. James Webb's most recent imagery of ARP-220 reveals even more detail. It captures faint tidal tails, elongated streams of stars and gas, stretching out from the main bodies of the merging galaxies. These tails are evidence of intense gravitational interactions between the galaxies. Also visible are reddish and orange filaments believed to be scattered organic compounds, which provide additional insights into the complex chemical processes occurring within the merger. The observation of ARP-220 is more than just a visual spectacle. It provides a laboratory for understanding the chaotic, creative forces that shape galaxies. Adding to the telescope's list of paradigm-shifting discoveries, JWST has also identified some of the oldest and most distant galaxies ever seen. These primordial galaxies lie at the very edge of the observable universe. Initially, scientists questioned the authenticity of these galaxies, suspecting they might be closer galaxies masquerading as older ones due to their brightness. To verify their suspicions, researchers shared the data globally. To their amazement, the James Webb Space Telescope confirmed that these galaxies are indeed real and incredibly ancient. The light from these galaxies has taken more than 13.5 billion years to reach us, giving us a look at the universe when it was only 350 million years old. This verification is important, as it reinforces one of JWST's main objectives: to study the early universe and how the first stars and galaxies developed. Spectral analysis confirmed that 4 of the 6 newly discovered galaxies have extreme redshifts, suggesting they formed just 300 to 500 million years after the Big Bang. Surprisingly, these galaxies appear to lack heavy elements such as carbon, implying they are composed of primordial matter, further evidence of their ancient origin. However, what has really shaken the scientific community is the size and maturity of these galaxies. Some of them are up to 10 times more massive than the Milky Way, an astonishing fact considering the universe was still in its infancy when they formed. This discovery throws a wrench into existing cosmological models, particularly the Big Bang theory and the theory of cosmic inflation. Theoretical physicist Dr. Michioku has said that these results could compel us to rewrite textbooks. In his view, it takes billions of years for a galaxy such as the Milky Way to evolve to its present shape, so the presence of massive galaxies so early in the universe's history is an absolute enigma. Further deepening the mystery, NASA recently revealed another discovery: a galaxy cluster located just 650 million years after the Big Bang. This cluster is still in its formative stage and is expected to evolve into a massive structure similar to the Coma cluster, one of the largest known galaxy clusters. Thanks to JWST's precise instruments, including its FP spectrometer and near-infrared camera, NIRCam, scientists can now measure the velocities of individual galaxies within the cluster, confirming that they are gravitationally bound and forming a protocluster. NASA scientists liken these galaxies to drops of water in separate rivers that will eventually merge into a massive cosmic stream. This visualization helps convey the extraordinary nature of galactic evolution and interaction. Observations like these not only deepen our understanding of the early universe but also raise important questions about how the universe evolved so quickly after the Big Bang. All these discoveries contradict long-held assumptions about the origin and development of the universe. Although the Big Bang theory is widely accepted, recent data from the James Webb Space Telescope shows that our understanding may be incomplete. The presence of large, mature galaxies only a few hundred million years after the Big Bang raises doubts on how the universe expanded and evolved. Some scientists argue that the current cosmological inflation model may have significant flaws. Others point out that the Big Bang theory still cannot adequately explain what triggered the event in the first place and how it fits within the laws of thermodynamics. The James Webb Space Telescope is doing more than just peering into the distant past. It is redefining our entire cosmic narrative. Every image it sends back, every data point it records adds another piece to the puzzle. While we may not yet have all the answers, one thing is certain: we are closer than ever before. These groundbreaking discoveries are not only expanding our scientific knowledge but also igniting the imagination of people around